Assalamu alaikum students. Today's our topic is about the numericals of the chapter properties of matter. First numerical says a wooden block measuring 40 centimeter, 10 centimeter, 5 centimeter has a mass of 850 grams. Find the density of the wood. Now this is a situation in which there is a wood and one side of it is of 40 centimeter, one side is 10, and the height, let's say, it's 5 centimeter. So the total volume of this wooden block is going to be 2000 centimeter cube. And the mass of this is 850 grams or 0.85 kilograms actually in this case. So the data which is given to us is mass, which is 850 grams. So we have to convert that into kilograms. So we have to divide it by 1000. So our answer will be equal to 0.85 kilograms. The volume, it is length multiplied by breadth into height. We get 40 multiplied by 10 multiplied by 5, which is equal to 2000 centimeter cube. Or in scientific notation, we can write it down as 2 into 10 to the power 3 meter cube. This is a scientific form. That means dot after the first digit. Density. We have to find the density and we know the formula of density. Density is equal to mass per unit volume. Now, here is the formula for us. D is equal to M over V. If we put in the value of mass, which is equal to 0.85, the volume is equal to 2 into 10 to the power 3. The density is going to be 425 kilogram per meter cube. This is the required answer as well, right over here. Moving on to the question number 2, how much would be the volume of the ice? Now, volume of the ice is required formed by freezing 1 liter of water. First of all, we'll take 1 liter is equal to 1 kilogram. Next, mass will be equal to 1 kilogram, which we already have now. And the density of ice is given by 0.920 kilograms per liter, you can say, because that is the volume, liters. Now, in this case, the density which is given to us is 0.92 kilogram per liter. So we have to find the volume now in this case. So as we have the formula D is equal to M over V, now we have to find the V actually. So it will be M divided by D. And we have the mass already, which is 1 kilograms. So D is equal to M over V. Rearranging this equation, it will be density, which is 0.920 of the ice. We put in over here, we have to find the volume in this case. Rearranging the equation, V goes up and 0.92 goes down. So it can be written as V is equal to 1 divided by 0.920. So if we write it like this, and we convert it into fraction as well, this decimal point. So it can be written as 920 divided by 1000. 1000 goes up. It can be written as 1000 divided by 920, which is given right over here. So 1000 divided by 928 is going to be 1.09 liters. So we can say safely now the volume of the ice basically expands in this case. Calculate the volume of the following objects. An iron sphere of mass 5 kilograms. Okay. Now this is the iron filing which we have taken over here. In this case, the iron filing which we are considering is of 5 kilograms. And the density of this iron filing is given to, iron sphere is given to us is 8,200 kilogram per meter cube. And the second part says 200 grams of lead shot have a density of 11,300 kilogram per meter cube. And the third part says that the gold bar of mass 0.2 kilogram has a density of 19,300 kilogram meter cube. Now, the formula of this will remain, I think, the same because density is equal to mass per unit volume, and we know by rearranging this equation it will be V is equal to m over d, where m is the mass and d is the density. Let's solve these equations. It will be solution. The mass is given for the first case for the iron sphere is 5 kilograms. The density for iron is 8,200. The volume of iron, basically we have to find it out. So it will be volume is equal to mass per unit density. Putting in the values of mass, which is 5 kilograms, divided by density, which is 8,200, we'll get the volume is equal to 6.1 into 10 to the power 4 meter cube. This is the required answer for the first case for the iron sphere. For the second part, the mass was given to us, which is in grams, so we have to convert that into kilograms, so we have to divide it by 1000. So 200 divided by 1000 is going to be 0.2 kilograms. Next, we have the density of this lead, which is 11,300 kilogram per meter cube. So again, using the same formula, V is equal to m over d. Putting values of m, which is 0.2 divided by 11,300. So the volume is equal to 1.77 into 10 to the power minus 5 meter cube. M is equal to 200 grams, and we can convert that into kilograms by dividing it by 1000. So we have now the new density of a coal is 19,300, which is of coal. Again, the volume formula will remain the same. To find the volume will be equal to mass per unit density. So it is 0.2 divided by 19,300. So our answer is 1.042 into 10 to the power minus 5 meter cube. That is the required answer as well. Question number 4 says a density of air. The density of air is given to us, which is 1.3 kilograms per meter cube. Now this is the density of air in specific volume, you can say in this case. And find the mass of the air in the measuring volume of a room, which is 8 meters, 5 meters, and 4 meters. That means there's a room which has 8 meters, 5 meters, and 4 meters volume, and the density of air is 1.3 kilogram per meter cube. Now we have to find the mass in this case. Again, I think the formula is the same. D is equal to m over v. From this we can say m is equal to d into v. So we have to multiply the density multiplied by volume. So here's the solution. We have the density, which is 1.3 kilogram per meter cube. And the volume which is given to us is 8 meters into 5 meters into 4 meters, which is 160 meters cube. We have to find the mass. We have the formula D is equal to m over v, and m is equal to d into v. So we are multiplying 1.3 multiplied by 160. So the mass which is of the air is 208 kilograms in a room. Now, in this case, if we remove this one, now in this case it says a student presses her palm by a thumb with a force of 75 Newton. How much would be the pressure under the thumb having a contact area of 1.5 centimeter cube? Now here is, let's say, a hand, we draw it, and this thumb over here, and a student basically presses her thumb. The thumb is too large now. Let me clear it out. Here's the thumb, and she is curling her fingers. And the pressure, here's the force applied, which is 75 Newton. The area under which the force has been applied is 1.5 centimeter square, and we have to calculate the pressure at this point. How much pressure is she feeling? Now, the data which is given to us, which is 75 Newton, area which is given to 1.5 centimeter square, or we can convert that centimeter into meter by dividing 100 into 100. So 1.5 divided by 100 into 100, or 10,000, it will be 1.5 into 10 to the power minus 4 meters square. So pressure is equal to, we have to find out, and we know the formula of pressure. Pressure is equal to force per unit area. Now pressure is equal to, we know that force is 75 Newton and the area which we have is 1.5 newtons per minus 4. Putting in the values and solving it, it will be 15 to 10 to the power 4 Newton meter square inverse. Now this is not in scientific form or scientific notation is not right. So what we have to do, we have to rearrange the decimal point in this case. So the decimal point from here moves from here and it will increase, the power increase from 4 to 5. So the new values which we have now, P is equal to 5 into 10 to the power minus 5, not minus, 5 into 10 to the power 5 Newton meter per meter square. And this is our required answer in this case as well. Moving on to the sixth question, it says head of a pin is a square of side 10 millimeters. Now here I'm drawing a pin and it is narrowed at a certain point and it is of cubic form, sorry, not cubic, square form, and one side of it is 10 millimeters. So this side must also be 10 millimeters. So this is the area which we are talking about. And the force applied on this pin is 20 newtons. Now in this case, we have the solution and we have to find the pressure in this case. Again, the formula is going to be the same for pressure. Pressure is equal to force per unit area. Now in this case, first of all, we write down the side of one side of the square, which was 10 millimeters. So we converted millimeters into meters by dividing it by 1000. If there's an area, so we have to do this 2 times. So 10 divided by 1000 and multiply by 10 divided by 1000. It will be equal to 10 into 10 to raise power minus 4 meters. So that is the area which we are considering right now. And the force which is given to us, which is 20 newtons, the formula for pressure which we have already, which is F over A, and pressure will be equal to 20 divided by 10 to the power minus 4. So it will be 20 newtons power 4, but still it is not in scientific form. So we will convert this into scientific form. So it will be P is equal to 2 into 10 to the power 5 Newton meter square inverse. So it can also be called as Pascal. Pascal is the unit of pressure. Question number 7 says a uniform rectangular block of 20 centimeter and 7.5 centimeter, 7.5 centimeter, and a mass of 1000 grams stands on a horizontal surface with the longest edge vertical. Now this point is very important. Longest edge vertical. Find the pressure exerted by the block on the surface and the density of the wood. Now here's the situation. Here we have a wooden block first of all, and one side is 7.5, one side is 7.5, so that it is the longest part is like this. So this is the block of wood standing like this, and this is the pressure applying on this area because this part is 20 centimeter in height, so it is vertical in this case. And this is how we can basically represent the whole block in this manner. So 7.5 multiplied by 7.5, that is the area which is under the pressure of this whole block, and we have the volume of it, which is 20 centimeter into 7.5 into 7.5. And we also have the area in this case, which is 7.5 into 7.5. Now, in this case, the volume, which is in centimeters, we have to convert that into meters. So we'll divide centimeter into meters by dividing by 100 in this case, as well in this case, as well in this case. So 20 divided by 100 multiplied by 7.5 divided by 100 multiplied by 7.5 divided by 100. So it is equal to 9 divided by 8000 meter cube. Now, if we want to calculate the area, it will be length multiplied by width. It will be 7 divided by 100 because we are converting into meters, and the width can also be converted to 75 divided by 100 into meters. It will be 9 divided by 1600 meters square. So that is the area which we are talking about. Moving on towards the pressure part. Now we know the formula for pressure and the density also. Now in this case, the mass which is given to us, which is 1000 grams, which is equal to 1 kilogram, and the force which is given to us as weight, which is mg, which is 1 multiplied by 10, because mass was 1 kilogram, the value of g is 10, so 1 multiplied by 10 is 10 newtons. So we have the force with us and we have the area with us as well. So force per unit area is known as pressure. So 10 newton divided by 9 divided by 1600, this can be written as 10 divided by 9 multiplied by 1600, so 1600 goes up. So the pressure which is given to us is 1778 Newton per meter square. So this is the situation which we have for the pressure. Now for the density part. So the second part is for density. Density is mass per unit volume. We have the mass. We have the mass which is 1 kilogram divided by the volume, which is 9 divided by 8000, or we can rewrite it down by 1 divided by 9, so multiply by 8000. So our answer is density is equal to 889 kilogram per meter cube. This is the density of this wooden block. Now question number 8, it says a cube of glass of 5 centimeter side and a mass of 306 grams has a cavity inside it. Now this is the situation over here. Now this side is 5 centimeter, so as is this is a cube, so this side must also be 5 centimeter and this side will also be 5 centimeter, and it says that it is of 306 grams, so we have to convert that into kilograms, and it has a density of 2.55 grams per centimeter cube, and we have to find the volume of the cavity, and there's also a cavity in this case. Let me draw the cavity over here, and cavity goes into the cube, and here's the situation we have to calculate this much area of the cavity. So the side of the cube is given to us, which is 5 centimeter. We can find out the volume of the cube, which is 5 multiplied by 5 multiplied by 5. It will be 120 centimeter square. Sorry, centimeter cube, because it is a volume. Now, in this case, the mass is given to us, which is 308 grams. So we can keep it like that because our answer should be in centimeter square. So density is given to us, which is 2.55 grams per centimeter cube. We have to find the volume of the cavity. So we have the formula for density in this case. First, we'll find out the volume of the whole cube with the density, with the cavity as well. So it has a formula D is equal to m over v. From that we can rearrange because we have the density as well as the mass which is given to us. So the volume with the cavity is given to us, which is m divided by d. The mass is 308 divided by 2.55, which is equal to 120 centimeter cube. So without the cavity it was 125. With the cavity it was 120 centimeter cube in volume. So what if we remove this whole cube 125 from this whole cavity part? So what is left behind? Only the cavity volume will be left behind. So the volume of cavity will be equal to the total volume minus the volume of the block with the cavity. So 125 minus 120, we will only get the value and the volume of the cavity, which is equal to, the volume of the cavity will be equal to 5 centimeter cube. And that is our required answer as well. An object has a weight of 18 newtons in air. Its weight is found to be 11.4 newton when immersed in water. Calculate the density, its density, and can you guess the material of the object? Now, here's the situation. Here's a silvery color and we are putting it into water. So as we can see, the water level rises and the weight basically decreases. Now we have two things with us. The weight when it was in air, which is 18 newtons, and weight when it was in water, which basically decreased, which is W2, which is 11.4. So we have to find the density, and from the density we can find out which element this really is. The density of water is taken to be as constant, which is 1000 kilogram per meter cube. The formula for this one is density of material is given by W1, which is the weight of the material in air divided by weight of the material in air minus the weight of the material in water, or you can say in liquid, which is W2, multiplied by the density of water. So putting in the values, it will be 18 divided by 18 minus 11.84 multiplied by 1000. And if we continue 18 divided by 6.6 multiplied by 1000, it will be equal to, putting in the values, it will be 30,000 divided by 11, which will be approximately equal to 27,000, sorry, 2727 kilogram meter per cube, which is the density of aluminium. This density is of aluminium. So that is why we can say that this element which was immersed into the liquid was aluminium. Moving on to question number 10, it says a solid block of wood of density 0.6 grams per centimeter cube weighs 3.06 Newton. Now the force is given to us, or sorry, the weight that is given to us in this case. In air, determine A, volume of the block. First of all, A part, we have to find the volume of the block. B part, the volume of the block immersed when freely in liquid of density 0.9 grams per centimeter cube. Now there are two situations in which when it was in air, we have to determine the volume of the block, and we have to calculate when it was immersed and what is the volume of the block immersed when freely in the liquid of density 0.9. Now there are two situations. First of all, we find out that we have the density, which is 0.6 grams per centimeter cube. We have the force, which is 3.06 newtons. From that, we can calculate the mass. Mass is equal to weight divided by the gravitational acceleration, which is 10. Putting in the values, it will be 3.06 divided by 10. It will be 0.306 grams, or we can say 306 grams in this case. So volume is to be calculated in this case. So we have the formula density is equal to mass per unit volume. Using this formula, we can say that volume is equal to mass over density. So mass is how much? It is 306, and sorry, the density should be written over here. Density is given to us is 0.6 grams. So if we put in the values, it will be 510 centimeter cube. And this is our required answer, that this is the volume of that block. Moving on to the density of the liquid, which is given to us, which is 0.9 right over here. And the mass also given to us. Now we can find out the volume when it was immersed into the liquid like this. See, the volume of the water level also increased. The volume inside the liquid now is going to be volume is equal to mass over density. So it will be 306 divided by 0.9. Now the volume is V is equal to 340 centimeter cube. So this is the new volume when the material density has changed from 0.6 to 0.9. Moving on to question number 11, it says a diameter of a piston of a hydraulic press is 30 centimeter. How much force is required to lift the car weighing 20,000 Newton on its piston if the diameter of the piston is pump is 3 centimeters? Now here we have a hydraulic press. Over here we have one small diameter which is of 3 centimeters, and there's a larger diameter over here which is of 30 centimeters. So we are applying the force in this case on one side, and it will lift on the other sides. So forces are involved over here. When the area of this one is smaller and force is applied, the pressure which goes into the liquid will be distributed equally in all directions. So P over here, that means pressure over here, will be equal to the pressure over here. We have to keep this in mind. Now, as we push it, as we can see, the level of this piston basically increases, which can lift the car up. Now we have to calculate how much force was being applied at this point. So we have the distance, or we can say the diameter of the piston, which is over here, which is 30 centimeter. and the radius, because it is in circular form, which is 30 divided by 2, which is 15 centimeter. So we can calculate the area of cross section of this piston A, or we can say F1 in this case. This force lifting up is F1. So A is equal to pi r square. So area of this will be pi multiplied by 15 square. If we take square of 15, it will be pi multiplied by 225 centimeters square. So F1 we have is 20,000 newtons. So we have F1, which is 20,000 newtons. So we have to calculate F2, how much force has been applied over here. So F2 we have to calculate, which is over here. F2, how much force applied over here, and what is the diameter in this case? We have 3 centimeters, we take half of that. So the distance or diameter of the second piston, or we can say F2 piston, is D is equal to 3 centimeter, or we can say radius R is equal to D divided by 2, which is equal to 3 divided by 2, 1.5. Putting in the values in the same cross section area, A will be equal to pi into 1.5 square, or we can say pi is equal to 2.25 centimeters square. Getting the answer of these two areas and these two forces, we are equating them both. F1 divided by A is equal to F2 divided by small a. That means pressure in both the cases will remain the same. In this case, F1 divided by capital A in this case, as well as F2 divided by small a in this case. So if we rearrange and we can find out the value of F2, A, small a goes to the side. It will be F2 is equal to A into F1. It will be equal to 200 Newton. So that is our required answer. 200 Newton is going to be applied over here, so that we can find out the force of the piston by which it was being pushed. So it can push 20,000 Newton on the other piston. Question number 12 says a steel wire of cross-sectional area, that means area is given to us, 2 into 10 to the power minus 5 meters square. It is stretched to 2 millimeters. That means the change in length, which is 2 millimeters, by a force of 4,000 Newton. Force is given to us. Find the Young modulus of the wire. The length of the wire is 2 meters. Now, original length is also given to us. Now, here's the data. First of all, the cross-sectional area is given to us, which is 2 into 10 to the power minus 5. The force is given to us, which is 4,000. The original length is 2 meters. The change in length is 2 millimeters, or 10 to the power minus 3 meters, we can say equal to. And we have to find the Young modulus. As we know the Young modulus formula, F into L naught divided by A into delta L. It will be Y is equal to F 4,000 multiplied by 2 divided by 2 into 10 to the power minus 5 into 2 into 10 to the power minus 3. So if we cancel out these twos with this 4, it will be 2,000 divided by 10 to the power minus 5 into 10 to the power minus 3. So it can be written as 2,000 divided by 10 to the power minus 8. Now this can be written as 2,000 into 10 to the power 8, because this 8 goes, 10 to the power minus 8 goes up. It will be positive now. So it can be written as 2,000 into 10 to the power 8, but it is not scientific form. So the decimal is straight right over here. So it has to move 3 decimals over here. So it increased 3 decimals. So 3 plus 8, it can be written as 2.0 into 10 to the power 11. So here is the right answer. So 2 into 10 to the power 11 Newton per meter square. That is the required answer as well. I hope you enjoyed today's lecture. Inshallah, we'll meet again. Allah Hafiz. Bye-bye.